Hello.
Hello.
Let's keep a couple of minutes so if anyone else wants to join. I knew of the two guys that they wanted to join for this call. Otherwise, we will start. But yeah.
Hey, everybody, we'll get started in a few minutes.
Hello, Paul.
Hey there, Hector, how are you?
Doing good. What about you?
Doing okay. How's everybody else doing today?
Hi, Paul.
All right, why don't we get started? So this will be Tuesday, December 8th, 2020, Kubernetes SIG Multicluster. Hector, you're on the agenda first. with KubeFed beta roadmap.
Yeah, so some of you or some people in the community has asked what is the state of QFED and when it will become beta and what does need to be done. The idea for this meeting, or what I added to the agenda, this item was more or less to share our thoughts about QFED to be marked as beta. And I can start a presentation, but it will be super brief. Just a slide. 1 second, I will share the screen. Maybe you have to help me to this to share the screen, Paul. I cannot. So
1 second. 1 second. So do you have the control to share your screen now?
No. I mean, yeah, otherwise I can simply share the link and then state it.
You know, something changed about this recently. I'm going to try to log back in and I will be right back. I'm unsure of what is going on, but we had the same thing kind of happen last week.
Okay.
So let me try to log back in. 1 second.
All right.
And you still don't have the control?
Okay, let me try again. Yeah, I say host disable participant screen sharing. Anyway.
Yeah, I guess I need to take an action item to understand why this appeared to stop working. Sharing the doc for now works.
I hope, yeah, I hope you can access to it, but it just has the same one slide. So I will go through it. Mainly, the idea is that we have Mark II features has deprecated. The two of them we consider that they can be achieved with current third-party tools such as SIG Multicluster, Istio for some of these features that have been Mark has deprecated. The features are alpha and are kind of increasing the maintenance. Yeah, we consider there are other better possibilities instead of using QFED, as the purpose was basically to federate resources across clusters. So the second point, in order to become beta after these two features are completely removed, to mark as beta QFED, just to remind that whose reconciler feature has been marked as beta. So yeah, we will mark what is in there, which will basically will be this feature plus the scheduling preference feature. After that, the intention is to disable scheduling preference in order to then proceed with the next steps, which means mainly to split into the current repository, having two modules, like two different modules. So QFED will remain as a repository, but will be composed of multiple Go modules. And one Go module will be what we call QFED core, which will be only focused on federation of resources. And the other model will be the QFED scheduling, where this scheduling preference feature might live and could evolve independently of the core. So yeah, once these steps are achieved, we will consider Mark has beta QFed. Yeah, probably new features might land in between, but these 3 points in the slides will be the ones that they will define the state where QFed can be considered as beta.
Hector, I think you should be able to share your screen now. I found where that option was moved to.
Okay, yeah. I think
Tricky.
sounds good. Well, I think I hope you might able to see. Oops. Right? Can you see my screen?
As clear as a bell.
Awesome. So yeah, I repeat myself again. These 3 steps are the ones that we consider in order to be stable, or in order to have the core of QFed, the functionality, or at least the functionality has been enabled by default, and the functionality that try to pursue the same objective or goal, which is federated resources across clusters. The rest should be removed in order to be able to focus on certain maintenance goals, and in order to have some stability, and mainly because there are other third-party tools that they can achieve better these kind of features.
So let me make sure that I heard this. And if I can summarize, it sounds like the generating new APIs, joining clusters to KubeFed, and distributing resources will advance to beta, and basically the rest of the features will be alpha, and the federated ingress and service discovery ones will be removed after deprecation, right?
Yeah, that's correct. Yeah.
That seems very reasonable. So absolutely no argument against any of that from me.
Yeah. Okay. So yeah, if anyone has questions, ping me on the channels or right now. Otherwise, yeah, I will stop sharing.
All right.
Cool.
Okay, well, thank you, Hector. Kevin, I think you're up next, and you should be able to share your screen just fine.
All right, thank you. Let me share the screen. Hold on a second. Oops. Okay. All right. So last time I think we actually have some maybe concepting not quite clear. So I would like to go through it first, maybe just to give the very high level what we are trying to do, and then I can quickly show a demo.
Sorry, Kevin, we're seeing a Slack window.
Oops.
I'm not sure if you have multiple screens, but I'm seeing a Slack window right now.
Sorry, maybe I chose the wrong window.
Yeah, I see a 1 in the corner of the screen. Maybe that's material.
Is this one now? Oops. Oh, sorry. I chose the wrong window. It should be the right now.
Yeah,
okay,
we're seeing Google Slides.
Okay, so I want to first to clarify what we are trying to do, and I also refined the architecture and the concept graph. So maybe we can first go through that, and then after a quick demo, we can take a look at the API, what we are designing now. So based on the Federation V1 and V2, so we actually think about that. We want to provide a kind of turnkey solution for the end user, so they can easily to use what they are already familiar with, the Kubernetes native API definition for the federated application. So actually, the concept is called the template in V2. And also we need to set up the standalone policy API. So basically the placement API. And in the meanwhile, the mapping, so it should be a resource here. The mapping between the policy and the resources should be one to n. That means multiple resources can be propagated by one policy. Then it's much easier for the user not to repeat filling up the spreading preference fields when they every time they trying to create a federated application. And the third thing is that also the override API, the override, we think we need to also provide a standalone API because it's actually more cluster relevant thing, and actually we can set up from a cluster relevant perspective. And also the idea to make it standalone is that we want to share the override rules. That means that when people have multiple federated resources go into a same cluster, they may share some of the override rules. All right, so I'm going to skip the landscape thing because we already covered it last week. And for the architecture, I want to repeat that. So K Amada is the kind of a name of our prototype. We will have a dedicated API server to offer the three standalone APIs and also the member cluster APIs. And we will have an dedicated another scheduler to do the scheduling decision for propagating, separating the resources to different member clusters. And others are not quite special. So on the right is the kind of concepts. So the user input are resource template. So these are exactly the same as Kubernetes API definition. And also user can create the propagation policy either earlier than the resource creation or after the resource creation. And also they can set up the override policy from the more cluster relevant perspective. So actually, I think this graph is kind of clear how these concepts are involved together. And for the resources being scheduled and also expanded with the override fields, they will be stored in the a special namespace called the execution space. It's per cluster member cluster level, and we use the work API to mirror the status between the federated control plane and the resource in the actual member cluster. So next one is actually a more detail about the API workflow. So just to give a idea how the components and the APIs interact with each other. All right, so I think maybe we can first go through the demo. Okay, so I already have a cluster set up, and we have the Amadar already deployed, and we have the member cluster. I added one member cluster. So in the member cluster, currently we are just fetching the Kubernetes API version, but Kubernetes version, and later on we will also fetch all the APIs enabled in this cluster. And on this cluster, we don't have much labels and other marks, but that's enough for doing the demo. And also we are currently pointing the token of accessing the cluster into a separate secret. So with this, it's much easier to just give the read access to the application teams in a organization, so they can query how many available clusters in the system, and they can also customize the propagation preference. All right, so here I added two YAML. So one is the deployment. This is just a normal one. And also the policy. So it's also very simple that we have the resource selector that will match that deployment, and the placement process that I want to propagate this deployment to the member cluster one. All right, I'm going to create this. All right, and also on the top, I have the, we can watch the deployment. All right, so actually the what happens in the behind is just as we showing in the graph, that the propagate the policy controller will get the notification that there's a policy, and it will match the deployment to the propagation.
So Kevin, is it okay if I ask a question here?
Yes, yes.
One of the things that I remember hearing a question about last week, or it surfaced, and I wondered if we could talk about it explicitly, is it seems so just to clarify, on the top pane of your TMUX session, it looks like you are connecting directly to cluster 1 and not to the management cluster, right?
Sorry, I didn't get the question.
I was wanting to establish that in the top pane of your terminal, you're connected to member cluster 1,
yeah,
and on the bottom pane, you're connected to the management cluster, right?
Yes.
Okay. Yes. And so the question is, and I don't think that we explicitly got this, but I was wondering, is there any way that you provide status back through the the management clusters control plan.
Yes, we just not yet implemented that. So so that's why we're querying to the member cluster.
Okay. What do you plan for that to look like when you do implement it? Or are you able to say yet?
So actually we it's the first step is we will fetch the status and store it in the work API, and also then we will simply aggregate all the status struct to the binding API, and
Okay.
we are also thinking about more advanced kind of aggregation and abstraction of the status, but no progress on that yet.
Okay.
Yeah, I can share the structure definition if you like to know.
Well, I didn't mean to derail your demo.
Mhm.
I got enough to answer my question for now.
Okay.
Kevin, I have a question, if I
Mhm.
might ask. There are two exactly. One is so the deploy resource that you create. Could you open it again so I can see if it is a different type of resource? Is a federated resource name, or the one that you create in the managed cluster? That's one of curiosities I have.
You mean how user create a
Yeah. My question goes, in that
Mhm.
direction. So you here have a selector template, right?
Mhm.
So my question is, how do you distinguish what you want to deploy on the management cluster and what you want to deploy on the federated clusters?
Yeah, so maybe this one is much clearer to help understand. So we actually, so the Kamada, they have its own API server to store the objects, even though we use the Kubernetes API version and the kind, but actually it has nothing to do with the Kubernetes cluster. So we have the API server, commander, controller, manager, and also the scheduler running separately. They are not aware of whether they are running inside a Kubernetes cluster or they are just running
All right.
on a machine.
Okay, I see. So then my question is, where the validation of this object is done, right? If the deployment is a valid template, for instance, or if you have a
Mhm.
custom resource, where do you validate that this custom resource will be federated is valid, for instance?
You mean the validation?
Yeah.
So a validation. So actually, validation. I think for example, the Kubernetes core API definition, they already have the validation implementation, right? So we can. So this API server, we're actually using the Kubernetes API server binary to run that. So that part, I think that it's easy, and for the so it's actually a full-featured Kubernetes API server, so we can also install CRD there, and also people can customize their validation against the customer resource.
I see. All right. And the last question is, based on the arrows in the graph, I assume it's a push model, right? There is no pull model. You don't deploy anything, any daemon on the clusters, right?
Well, actually, so we have a kind of a abstraction layer here in the landscape, but it's fine. So we want to provide a layer to make it either users want to use push-based model or pull-based model. The difference is difference is that whether it's done by the control plane or it's done by the agent in the member clusters.
All right. Okay. That's it. Thank you.
Okay, so I think we can move on to the little bit more details about the APIs. So for the federated resource, the template, I'm taking the deployment as example, but actually all the API resource types are similar. So the major idea of what we're doing now is that we want to provide the best compatibility with the people today. They're using a single Kubernetes cluster. So yeah, the federated resource definition is actually exactly the same with Kubernetes API. And for the propagation policy, maybe let me play it. All right, so for the propagation policy API, it's actually the standalone placement API. So we basically have the selector field. This one is to match the resource they want to propagate or the policy want to apply to. And also the propagate dependency is kind of a very advanced feature for automatically propagate the config map that is used by a deployment, for example. So the placement is actually the scheduling preference, whether where the clusters these resources the user want them to be scheduled to. So we basically have the cluster affinity. It's kind of very self-explaining. Users are able to enumerate the cluster name or just match the clusters by the label selector. And also we also borrow the concept of taints tolerations to the federation layer. So the user can mark some clusters with the taints for special usage, and only the resources spread by the propagation policy that have the corresponding toleration can go there. And the spread constraints is kind of defining how to separate the resources between each other. So either the system can spread the resources by label or by fields. So actually the idea is to dynamically group the clusters into different groups. For example, we can group the clusters by zones or by regions or also by cloud providers or by other sort of things. And we can also restrict the number of the groups people want to their resource go to. Yeah, so the override API is new. We are still working on designing that. So the basic idea is that the override, we think it's more kind of cluster relevant because for example, we have clusters in different regions or different environment. For example, some clusters are on-prem and some clusters are in the public cloud. We also have the different container image registry in the different environment. So we can use the override policy to change the image prefix to save the downloading bandwidth and the latency stuff. And also, for example, the storage class, because in different environment we may have different storage backend setup. So so the idea is that for some of the resources going to a certain set of cluster, they may share a group of common override rules. So that's why we make it a standalone API. So it's also looks a bit very similar to the policy API because we make all these API standalone. So we have the resource selector here to restrict what kind of resource types this override policy will apply to. And also the targeted selectors here, because we are not actually propagating the resources. So here is just some rules to find out the clusters. So either a user can just enumerate by cluster name or use label selector to select a set of clusters. So overrides here for the initial release, with think we just make it easy. So we name it as plain text overrider. So it's actually the same way with what we have in the V2 today, but in the longer time, maybe we can have more advanced overrides, like just the match and change a certain prefix of an image.
Kevin, you have a question in the chat about kube control get.
Yes, let me turn.
I typed it in just to make it easier. If I deploy resources to a given cluster, specifically not through the KubeFed API server, so I go right to a cluster and deploy a resource. Is that resources then reflected? Or now do I have to get all the resources in my multiple clusters that I'm managing? Do I actually have to do two queries, one through the API server, the Kamada API server, Mada, hopefully I pronounced it right, Kamada API server, and then one actually to each of the other individual clusters, because the resources aren't collated all together.
That's a very good question. So you mean you some of the resources you are actually directly created through the member cluster, right? And some are created by the federated control plane, right?
Yes.
So actually, in the proposed landscape, we have another component here to solve this situation. So basically, we can have so the unified API endpoint here. Actually, you can just use a API gateway to do that. So it's basically a routing whatever your API requested to a certain cluster. So you can use kind of request context to switch between clusters. Then you can switch to the federated control plane, or you can also switch to directly to a member cluster. The benefit is that you don't need to collect everything to the federation layer, so it's kind of less resource consumption of the federation layer, and in the meanwhile you can access all these clusters in your system with the same token, and you can also enforce the same set of role binding stuff, because you have the unified API endpoint.
The unified API endpoint, if I associate my context to a cluster and say get pods, for example, will it get pods? Will it query all the pods on all the cluster members? Is it essentially a distributed query, or it goes off and launches gets to each specific member and then collates the responses, or is it, what's it actually talking to at that point? If I say get,
it's actually just routing your request to a single cluster.
okay. So is there a mechanism then in this landscape that says I can say get, and I get my pods over all my clusters, including ones that are essentially deployed through the multi-cluster control plane?
We not yet see this kind of scenario, but it's I think it we can also easy to build some loop on top of this to implement that.
I mean, it also would be interesting when I do that, or using deployments as an example this time. If I say get deployments, understanding which deployments are deployed through kind of the multi-cluster control plane and are essentially federated deployments versus ones that are bound specifically through non-fed, were deployed through non-federated means, right? Understanding the distinction at some point, I suspect will be a useful operation. And if I also go to a specific cluster member and I say get deployments, I suspect at that point, because I'm not going through the KubeFed API, I'm going to get a list of deployments and not be able to tell if those were placed based from the KubeFed distribution mechanism or directly against the cluster, because to a given cluster member, they look all the same. So I won't be able to tell from an operator if I go directly to the member and say get deployments or get any resource, unless there's unless you're annotating them as you push them down to the cluster member so that they're somehow marked.
When you say KubeFed in this context, are you referring to KubeFed the project or to the
KR Armada API? Sorry.
Okay.
So the problem is if I go through the no worries. That's my fault. If I go through the K Armada API and do push deployment, apply deployment, and then I go to the specific member and I say get deployments, that deployment looks like every other deployment on that member. And I mean, unless K Armada is also marking it somehow. And then as an operator, if I'm just happen to be going against that member thing, and I delete that deployment, which was deployed by the K Armada server, there's a reconcile issue and all those. I mean, how's that all being addressed? Because what does it mean if I go to a member and delete a deployment that was deployed by the K Armada server?
That's actually a very basic functionality we need to provide. So just in any case, if for example, a deployment is deleted directly from the member cluster, but it's actually created by the K Armada control plane, either the execution controller or the agent in the member cluster will recreate the deployment.
If I delete a deployment, the cluster member won't.
If you for example, the deployment here is created by the K Armada control plane. You directly delete the deployment here. So the if it's a push-based mode, the execution controller of K Armada will create the deployment according to the work.
So there's a reconciler?
Yeah.
Essentially. Okay, so that deployment will automatically show up back on that cluster.
Yes.
When you push resources to a cluster, are you annotating them so that when I look at that cluster, I have I can relate it back to the K Armada deployment?
Yes. Yes, we add the annotation to mark the resources created by the K Armada.
Okay. All right, thank you.
All right, so for the API, we just cover the overrides, and then is the member cluster API. So for the member cluster API, it's actually for example, the API endpoint field, if it's actually used only in the push-based model, but if it's a pull-based mode, it means actually we have the agents in different member clusters. The agents will register the member cluster to the control plane. So also even the member cluster are inside a private network or behind a firewall, doesn't have a public IP accessible from the control plane, it's fine. It's fine to go through the agent. So in that case, the API endpoint would be empty. And also the secret ref is used only in the push-based model. And we actually added some fields here in the spec instead of having them in the labels to kind of show it's the best practice while we are serving the end users. And also in the status, besides the general very high level summarize of the status, we are also fetching the Kubernetes API version, Kubernetes version, and all the enabled API versions. So later on, we can check in the scheduling stage whether the a candidate cluster, they have the enabled the target API version and the kind, and filter out the candidate before the actual resource going to the member cluster and the field. And also the resource summary, node summary, it's kind of a summary of the cluster, like healthy, how many nodes are there, and the usage of the whole cluster, so we can later on schedule according to the cluster usage. So that's the basically the API idea we have so far. And also in the graph, you can find there are another tool is the propagation binding. So this one, we are actually thinking it's a API for the controllers to interact with each other. So so I'm not introducing it here. And the propagation is if you attend the SIG meeting very often, you should be familiar with that. We don't have anything special on that. So that's the all the status we have so far. Any questions?
Yeah, so you've concentrated in this presentation and the last one on built-in types. This is supposed to work with custom resources too, right?
What do you mean supposed to work with it?
Let me rephrase that. So if I create a CRD on the management cluster, it's expected that I should be able to use like all of the features that you've described, right? When and I know that you're just prototyping now, but when you install a CRD on the management cluster, I guess if I'm thinking about, since CRDs based APIs typically are using like at least one or two webhooks, I guess I'm guessing to myself, and I guess this isn't a question, I'm thinking out loud, and I'm wondering maybe if you can confirm. If I register a CRD in the management cluster, I need to probably run the webhook for it in the hosting cluster that hosts the management cluster. Is that right?
So actually, you need to you mean this webhook to validate the CRD, right?
Right. Say it's a validating webhook, just for discussion.
Yeah. So actually, in this case, the register is the CRD is registered to the K-Armada API server, and we actually need to run the webhook here to talk to the K-Armada API server to do the validation. Yeah.
Right. So I wonder if we can just go up a level of detail or down, as the case may be. So say that I've got my CRD and I install it on the K-Armada API server, and it has a validating webhook. So I create a validating admission webhook resource on the K-Armada API server. That admission webhook resource has to point to a, normally I would expect it to point to a service that, like, if we forget about K-Armada and we're just talking plain Kube, I'd expect that admission webhook resource to point to a service that's on the same cluster. And so I guess my question is, will the pattern be when people register CRDs with the K-Armada API server? Since that API server isn't, or since the management cluster isn't really a fully functional cluster, it seems to imply that, like, you will typically host the webhook pods that will serve the webhook requests in the cluster that is hosting the management cluster.
Yeah. Yes.
Okay.
Won't those all hooks have to be propagated down to the member clusters as well?
Sorry, what's the last question?
Won't those hooks have to be propagated to each of the member clusters as well?
Well, actually, yes. For example, if not just the webhooks, but also you have the operators,
Right.
because the K-Armada control plane is actually just propagating the resources. So you need to have the operators in the member clusters.
So when I create or deploy a CRD, I deploy it against the K-Armada API server with policies such that it'll be deployed to each member where it'll be used, or I expect it to be used. And hopefully those policies will match when I create the instances of those CRDs as well, so that I don't try to create an instance on a member that hasn't already got the definition on webhooks. Is that fair?
Yeah. For example, you have the like YAML for running your operator. You can submit that YAML to K-Armada API server, and the K-Armada will help you to set up the actual operator in the member clusters. And then when you have the CRDs to the K-Armada, the custom resources to the K-Armada API server, and it can propagate to the member cluster, and you have the full function of the CRD and the operator in the member cluster.
I am going to call time on this for now, because we do have one last agenda item, and I think we're just about at time. So thanks for the additional presentation and demo today, Kevin. And I thought this was interesting material. Michael, you're up next with the final agenda item today.
All right. Thank you so much,
Right.
Paul. And thanks, Kevin.
Thank you.
Let me just see if I can share quickly here. This is just a really brief, hey, everybody. We're going to be having some conversations about things related to multi-cluster, maybe a bit more broad than just kind of where KubeFed has traditionally been. But, you know, a lot of the concepts, Kevin, I'd love to actually have you join us in this conversation as well. But basically, we've been working in this, myself and other team members have been working in a public GitHub org around open cluster management. And we had built some technology that originated in IBM and IBM Research, and then transferred some of that into Red Hat and have been working to open source that. And then we're looking to, you know, drive more awareness and understand some more of the use cases. So this Thursday at 10:30 Eastern or 15:30 UTC, we'll be hosting the first sort of community meeting. We will talk about a couple of different things in that first call, primarily around work management. So Kevin, in particular, the concept of work and distributing work across clusters. There's an API that we've been developing in the open as well. And ideally, you know, some of the things that we're able to focus and build as part of open cluster management would be appropriate for SIG Multicluster. There are some things that might be appropriate for things like SIG policy, maybe some things in the continuous delivery or GitOps community as well. But we'll just invite everyone who's interested to come and participate in the calls and let us know your thoughts on the use cases that we're discussing. Let us know what you think aligns to other parts of the community. This is very much a capability that we're focused on everything from how do we provision clusters, how do we attach that agent that does work distribution to clusters, how do we deliver continuous policies, how do we deliver applications, how do we drive observability. There's components that integrate with things like Prometheus and Thanos as well. So the reason it's a separate project is because we think, you know, it's hard to just digest all of that everywhere upstream at the same time. But there's definitely parts like manifest work is our work API that might be appropriate to consider in SIG Multicluster. We're actively looking at integrating things like cluster claim into the way that we think about managing clusters, integrating things like the multi-cluster service definition as well. So just to invite everyone, the links are in the agenda, but in particular, the meeting details are public here. The agenda doc is also public and publicly editable. So if you want to begin to add topics, we plan to do these every 2 weeks. So we'll probably end up missing one at the end of December because of US holiday, but after that, about every 2 weeks. And that's it. Just if you'd like to come join and participate in the conversation, we'd love to have you. Any comments or questions?
Could you give kind of a high level difference to what you've seen or similarity to what you've seen, what Kevin just presented?
Sure. So at a very high level, there are similarities for things like how we think about a cluster itself. So there is actually an API called Manage Cluster, which is similar to that member cluster concept. There's also an operator that's actually available on operatorhub.io to address the agent which registers itself with the hub. And when we look at things like propagation policy, that's probably an area that is where there's more divergence. We use a concept called placement rule. Let me pull up this repo here just for a sec. And the placement rule is actually used across both the way that we deliver applications and the way that we deliver policies. But placement rules basically work around the concept of label matching or match expressions, very similar to, you know, the way that services include endpoints and pods and things like that. So clusters, managed clusters is an API kind, has a set of labels. A placement rule considers the set of managed clusters that a user has access to, comes up with a similar concept of cluster decision that's consistent with that notion of propagation policy. And then the placement rule could get used by different kinds of controllers. It's used by a policy controller that delivers and syncs policies, that does active enforcement or audit. It's consumed by applications. You had asked the question about, can you view all of the pods across all clusters? And another component that we're working on getting into the open source is our search componentry, which does actually index all of the Kubernetes things from all clusters, puts that in a database built on that has graph edges so that you can find relationships. So there's things like that that correspond pretty closely, like member cluster and managed cluster, very close. Propagation policy and placement rule, a little divergence in some of the ways that we think about that. Everything in open cluster management are kube CRDs, with the exception of the way that we collect search index information. So everything ties naturally to a kube API server on a standard kube cluster. We primarily focus obviously on running it on OpenShift, right? I work from Red Hat, but the goal is to make it more general. We can still manage to any managed kube service, so an EKS, AKS, GKE, et cetera, are all managed to targets today. So kind of a whirlwind answer. We'll kind of start the first call on Thursday off with an overview, just to kind of provide a lay of the land. And then the intent is to do a deep dive on the registration API that is in Open Cluster Management, how a cluster can attach to a hub, and how work distribution, which is decoupled from registration, but how they can be put together to both register a cluster and address work. But you can take out the registration protocol that's in Open Cluster Management and still use the work controller as is, just with a different registration protocol. So we'll start with that as kind of the first deep dive, but the goal is to kind of look at all of these different areas around cluster lifecycle, policy lifecycle, app lifecycle, and observability, those 4 key areas.
Thank you. Question to the SIG, are we looking towards a reconciliation between these 2 projects, or a 1,000 flowers type of thing?
I am not interested in being a kingmaker or picking one.
Yeah, the intent of why did we have a separate project than just kind of going through SIG Multicluster is a great question. And in particular, there's a community repo where we try to talk about that. I think basically we see this space as also needing, I think Kevin used the term turnkey solution. I think it's a great phrase. I think there's a need for how we can kind of pull together different projects and make sure they work effectively together. It is 100% our intent that either part or all of this content ultimately join a foundation somewhere, right? CNCF, Kubernetes. But we've kind of found that there are certain things that align really well to slices of the community. For example, cluster registration, work distribution might be appropriate to consider in SIG Multicluster. Policy management, policy distribution might be appropriate for SIG policy. So
hate to interrupt, but I now have to drop. I'm not sure if you all will be booted, but I have to join another meeting. So I will.
No worries.
I
Just invite everyone to come on Thursday and we can continue this thread there.
All right, great. Thanks, everybody. Have a great day.
Bye, everybody.
All right.